Sir, for such a insightful session. Now I would like to invite Dr. Komal Kumari ma'am, Assistant Professor, Civil Engineering Department, BIT Sindri. She has done his BTech from MIT Muzaffarpur and MTech and PhD from IIT Kharagpur. Her research area includes the surface water and groundwater interaction at regional scale and optimization in water resource system. I now invite Dr. Komal Kumari ma'am to take a session on the topic of application of GIS in groundwater management. Give a big round of applause for Komal ma'am. Ma'am, please.
Thank you, Ayush. Am I audible?
Yes, ma'am.
Good evening, everyone. Already 4 days, today is the fourth day of workshop. We have learned a lot about fundamentals of remote sensing and GIS techniques, its real field applications, and its requirement in day-to-day life. You must have, all of you must have understood a lot of things. A lot of expert persons have visited our institute and joined us in our workshop. And in this process, in the fourth day, we are going to learn about more about groundwater surface water interaction. Uh, in that field, remote sensing and GIS techniques also play a major role. So I just want to show you a few practical applications. These are the contents which we will go through one by one. First of all, coming over introduction part, surface water groundwater interaction, as all of us know, it's still remains a challenging problem because surface water and groundwater both are complex in nature. Most of the time groundwater, it's difficult to deal with groundwater part because acquiring data and all plays a hectic role in this one. And another thing is that regional scale modeling, that part, at least when we want to model something on a regional scale basis, then we cannot go for computer modeling simulation sort of thing, because that can be applied on smaller scale only. So for the regional scale modeling, we used to prefer GIS techniques and remote sensing technique. Without its application, our job will not be done efficiently. So as we can see from this figure, there are two figures are there. In one figure, sometimes what happens that surface water contributes to groundwater, like in first one, like in second one. Okay, first one, surface water, groundwater is actually contributing to surface water, you can see in this figure. And in another one, surface water is contributing to groundwater. From surface water, water is seeping downward in the groundwater zone. And this type of a stream, when it contributes to groundwater, will be known as, we term that type of a stream as losing stream. But whereas when the stream gains water from groundwater, like in first one, case A, then this type of a stream will be known as gaining stream. So basically everywhere surface water interacts in more than two ways, like first case, like a gaining stream or losing a stream, or combination of both. Some of the part of the stream will act as losing a stream, and some another part will be acting as gaining stream. So we will be dealing with these three cases when we want to actually model surface water groundwater interaction thing. So basically, before proceeding, we should be knowing that how remote sensing and GIS technique will be helpful to interact, to study about the interaction among groundwater and surface water. First of all, it will be helpful in detecting the interface between surface water and groundwater. And also it will be helpful in mapping large inaccessible areas where we cannot visit physically and do collect data. Then in those cases, groundwater surface water data can be collected with the help of surface water, with the help of remote sensing and GIS techniques. And information extraction can be done using this technique also, like terrain, subsurface geology, features that control groundwater recharge and outflow, like that. And also groundwater potential index, like one of our speakers yesterday, he discussed in detail about groundwater potential zone mapping and other thing. So that can also be done. And next, what we can do, we can create a map also using overlaw weighted sum technique. And next, lastly, before after doing all this modeling thing, what we want to do, that whether our model is correct or not. For that part, we will be going for a validation of that map or model. So for validation, what we will do, we will collect some data from real field and compare with our modeling part. So in through literature survey, it can be observed that most of the study have been done in groundwater surface water interaction field also. This one is actually area of Damodar watershed, and out of that Damodar watershed, actually command area, which I will be discussing in this particular portion, will be only left bank main canal, which is shown in this slide. Command area is bounded by river Ajay in north, whereas Damodar river in south. Total area, total command area is approximately 5.68 lakh hectares, out of which 3.94 lakh hectare is cultivable command area. And 80% of, you can see from this figure that 80% of this part, total, this one, this red color boundaries, that is showing the boundary of study area. Whereas the 80% part, this blue line, this one is showing our Damodar river. So 80% of the part is lying in the LBMC. LBMC means left bank main canal, left bank of this Damodar river. And this one is right bank, this side. So basically, in this study, we will be dealing about only LBMC part, because the problem is there. Actually, in this one, you can see this map is representing rice cultivation. Rice cultivation, that means this green area. This green areas is representing Boro rice. What is Boro rice? Boro rice is nothing other than the rice which is cultivated during January to April. See, in January to April, during, that means non-monsoon season, during non-monsoon season, or in simple language, we can say that Garma rice. Most of you must have heard that. Actually, in that area, problem is due to Boro rice only, because all farmers cultivates, most of the farmers depend on for cultivation part, at least Boro rice cultivation part, they are dependent completely on groundwater, because during January to April, most of the areas don't observe any rainfall. So for cultivation or for irrigation of Boro rice, they extract groundwater. So in the next slide, we will be observing that because of this excess groundwater extraction for cultivation purpose, groundwater level is degrading day by day. For it, in this particular work, only 2 years data has been compared. See this one, for from 1986 groundwater level variation we can see in 1986 and in 2000. See, in this part, this region, in these zones, the where maximum Boro rice cultivation occurs, that in those areas you can see that BZL value is quite high. BZL value, that why minus values? Minus values is showing because we are considering ground as zero value. So below ground level, minus values like minus 15, minus 14, you can see here. So these values will be representing nothing other than below ground level water data, groundwater level data. Okay. So see, in the same zone, when in 1986 it was just minus 11 and 12, in that zone, in that range only, but whereas in 2000 it has reached up to minus 15. So you can see a large variation of groundwater level, that means degradation of groundwater level you can observe. It can be observed from this figure. Okay, and this figure is simplified in the simplified manner. I have tried to show this variation. So you can say dark color. See here, dark black color represents this range minus 8.83 to minus 5. That means maximum groundwater level degradation you can see that is visible in this zone. Why in this zone? You can see reason because in this area, see in the next figure, I have already shown boro rice. See here, boro rice maximum, this green color is what showing rice growing area. It has been represented here in the map itself, rice growing area. So what you can observe from this that in this region, see in 2012 when the boro rice growing area was scattered in this region only, whereas in 2013 just after a gap of 1 year only you can see the difference. Boro rice cultivating area is increasing day by day. So what will be the effect of that increase? Ultimately the load will go on groundwater only because we have limited surface water is limited, and discharge whatever is going through, whatever discharge is allowed mm, from the barrage itself, that is limited, that is not increasing. Rainfall is also not occurring during that time, January to April. So most of the farmers are dependent on groundwater only for cultivation or irrigation of boro rice things. So the difference can be observed from this figure. And one more thing is that to validate this one, this particular one, what was then in that one Python code was written, and using that code we have developed a model, simple surface water model and groundwater model, coupled model. So using that code only, this contour map was generated. And in this contour map what we can see that in this shown we can see inset area, we can you can see that a dotted portion has been highlighted here. So it's showing the maximum -1 or -5 thing is observed in this region only. Why? Because reason is same still. I am repeating the same thing. The reason was boro rice cultivation only. What you can do, you can go and do research over boro rice if you want to learn many more about this thing, because boro rice is the maximum maximum water consuming crop, maximum water consuming crop, because it needs standing water, and standing water that too during non-monsoon season. That is the problem. So it can be observed from figure that area under boro rice cultivation is typically decreasing over the past few decades. Furthermore, there is no political regulations to restrict also. This is the most important thing, because there is no any political regulations to restrict over exploitation of groundwater in this particular zone. So because of that thing only, uh, over exploitation of groundwater is occurring, which may reflect the sustainable use of water resources. Okay, and therefore a significant decrease in groundwater level can be observed in the command area from the results of this particular model, which has been developed using the help of remote sensing GIS technique as well as Python code. So it may be inferred that it can be efficiently coupled in the interaction model for the evaluation of interaction process between groundwater and surface water. We can efficiently utilize ARSGIS techniques, and also it is evident from this previous figure, this figure, that maximum model head values lies in those blocks of actually this thing. You must be wondering that what these lines, blue lines are representing here, apart from this contour lines. These are nothing other than the boundaries of blocks. Okay, boundaries of blocks, and we have implemented these boundaries of block as a line segment here, and also as an input parameters we have given the values of area of particular blocks, because and also another input parameter was river data, and left as a left bank boundary, Damodar river was there, and in the right bank Ajay river is there. So we have here we have input data, boundary condition, And after applying all this input data and boundary condition, we have got this result. And this result has also been validated using the practical data, which has been like extracted from field groundwater level data. Okay, so the minimum value lies in the few blocks which is in the downstream side, not this one, this side, downstream side of the Damodar river, minimum head values. And whereas the maximum head values is maximum head values can be observed in the upper reach. Why? You must all of you must have been uh, knowing about this, because see there here you can see that 67, 69 values. So there something, some complication is there, you can say simplicity is required, because this data is obtained from code itself. Okay, so this is actually relevant to our data of, that has been observed, yeah, that had been obtained from the ARSGIS values, and at least comparable. You can see from there also in the upper reach of this study area, we have maximum water level value. Maximum water level here, water level means groundwater level we are referring here. So see, you can see that in at least in 2012, boro rice areas, boro rice cultivating a rice growing area was not like significantly not observed in these areas, where significant variation or significant variation can be visible from just for 1 year. Land use map, you can see land use map, that means it's already been given non-rice area with you can say light brown color, and rice growing area with green color. So major variation can be observed from this figure, and due to that variation only hydraulic head contour map can be generated. Okay, and that can be compared. Minimum head values were observed in nearly all blocks of this Hooghly district. This one is actually, I should have shown that block wise naming also, actually that one missing here. Here you can see block names, it has been mentioned in this figure. Okay, these blocks which is situated in the downstream side of Damodar river is of Hooghly district, and this one is complete of Bardhaman district. Okay, so this is just a simple application. Using this, what we have done here, we have just applied, just extracted the data, whatever data is required for modeling purpose using GIS technique, and some of the work, some of the computational work, numerical model, for numerical model, some of the computational work has also been done using Python. So it's not like just from since last 4 days, you must be wondering like we have to just delineate work and delineate map and create map, that's it. So it's not like remote sensing GIS is restricted to that part only. We can utilize it in many ways. Okay, so that that's it from my side, and these are the few references. Thank you. Your voice is not coming actually, Ayush. It's not audible. And now it's fine.
On.
So we can end here.
Thank you,
We
ma'am.
can okay, okay.
Your session has just enlightened us. And thank you, ma'am. Thank you so much. And thank you, all our participants, for your enthusiasm and engagement. I hope you found today's session insightful and look forward to seeing you tomorrow.
Thank
Have a
you.
great
Thank
day.
you.
Have a great evening. Thank you all. A big round of applause for Komal ma'am.
So I'll end the call from here only.
Yes, ma'am.